Welcome, guys. Welcome to today's session. I'll be going through 2023 past paper. I'll be doing binary. I'm going to start with binary and then we'll go back to question one. So let me open the question paper, uh, files, and then downloads, and then uh, is it this one? Do Come on, open. Okay, this is semester test one. Okay, there we go. So here's the paper. So let's see. I'll come back to question two because yeah, so I've done a lot. I've done a lot. I've done a lot on question. I'll come back to question one. I mean, I've done a lot of text files and all of that. So I'm gonna scroll down, and then I'm gonna look for question two. So here's question two: problem modeling and binary processing. The company majors of the beach need to automate the processing of player data. Currently, the data is stored in a binary file format using only primitive types. So one thing about binary file handling, right? There's two ways of writing to binary. You can write to binary as objects, or you can write the information to binary as primitive types. So I'm gonna need to open draw.io to do a lot of to do a demonstration. So the files is stored the file stored following format. So they're stored in this following format. The data is in binary format. First int indicates an item. So we have item count, and they give us the data types. So yeah, let's see. Comparable, blah blah blah. Okay, we'll get back to that. So let's see. Let's discuss a bit about file handling, right? So draw.io. Let me open draw.io, create a new diagram, create. Okay, so here's our draw.io. So what is file hand? Remember file handling? The main purpose of file handling is so that we can store we can sort of like I would sort of like say we can store the information permanently. Remember when you run your program like this and you just run your program and it outputs hello world like that. What happens is the moment you exit this program, let's say you stop program, whatever information you are inputting, whatever calculations you're doing, you have to redo them again. You have to rerun your program and then calculate again. So that means data is temporal. You're storing temporary data. It's not permanent. So every time you want data or you want to test the application, you'd have to enter input. Yeah, it becomes a lot of effort. So if you want to store information permanently, you'd rather store it in a text file or in a file and save it on what we call secondary storage. You get to know more about that in computer science 3B. So secondary storage just means that which is your SSD, your hard drive, or your USB, or your CD or DVD. That's what we would call secondary storage because the information is stored permanently there. Even if you switch off your computer, when you switch it on, you still find your files, right? So if I switch on my computer right now, I'll still be able to find all of these files. That's the beauty of secondary storage. So we want to be able to store data permanently. That means we want to store it in a secondary storage medium. In this case, we're going to create a file and then store it in a file, and then that file is saved on the hard drive or on an SSD, depending on whatever storage you're using, whether using whatever secondary storage you're using, whether using SSD or hard drive. So let's look at binary file. Why? Let me just write. Let me open Notepad also. Come on, Notepad, open. Why is it taking so long to open? Okay, so let's open. Let me explain a bit about file handling, right? So there's two ways of writing to file. You can write it. You can write the file in a text format or in a binary format. Binary format meaning that there's zeros and ones. It's not really zeros and ones. Yeah, it's not really zeros and ones. So, but it's just for reference to so that you kind of get an idea. So basically, in binary format, right? The format that we're saying is basically it's stored in the language of the computer. That's binary format, which you can think of as zeros and ones. It's not necessarily zeros and ones, but you can just think of it in terms of that. Then we have text format, right? So it's saved in a text format. Like you see right now, you're able to read what I'm typing, right? Because it's in a text format. So when it's saved in a text format, that means it's saved in text in a human readable language. So there's two ways of storing to a file. You can store it as in a text format or a binary format, basically zeros and ones. So with that being said, why would we have these two ways of storing, right? So the reason why we have these two ways of storing is because let's talk about text format, right? Text format, right? There's these two concepts called encoding and decoding, right? Remember that computers only work with numbers. So if we are saving it as a text, then how does it know that it's gonna be a text? How does it know? How does it know to translate and do all of those things? There's this thing called encoding and decoding. So it's gonna encode it, and there's different encodings. What is encoding? I'd say in simple terms, encoding is basically mapping numbers to characters, right? So what do I mean by mapping numbers to characters? So basically, for example, you're gonna have the uppercase letter A should be represented by the integer number 65. And then the lowercase character A should be represented by the integer number 97. So you can that's what I mean by mapping numbers to characters. So basically when you encode something, right, you're basically transferring it, you're just transferring it from human readable text the to the machine equivalent number, right? To the machine equivalent integer. So there's different ways of mapping each character with the specific integer. There's the first one called ASCII, then there's the other one called Unicode. Java uses Unicode. It uses Unicode so it can support a lot of characters. You can even you can output text inside Eclipse in Chinese. You can do a lot. That's a powerful part with Unicode. What's the difference between the two? ASCII can only store roughly around 128 characters, I think. Yeah, I think it's around 128. No, it's not 128. It's 256. Yeah, I think it's 256 characters. Yeah. And then Unicode is Unicode, I would say I'm not really sure because Unicode is always expanding, it's always growing. So what's the difference between the two? The problem with ASCII approach is that the characters that we can represent are limited. You see, it's only 256. So what about if I want to represent characters to support the Brazilian language, or to support French, to support Italian, support Zulu, support all those languages? What it becomes a problem now if these characters are limited. So that's why they invented something called Unicode, which basically means universal code, right? So it's something it's a universal list of characters. So this Unicode involves more, it has more characters that can be represented with integers. So you can quickly go to your Google and then type ASCII table to see the different, to see what I'm talking about. So if you look at the ASCII table that we have here, right? If you look at the ASCII table that we have here, you see, let's say I'm looking for the uppercase. No, I swapped. Let me see. Okay, it's fine. Let me look at my notepad. Yeah, I said A65. Yeah. So if you look at this diagram, right? Look at the character A. It is represented by the integer number 65. And then look at the character A, the small letter A. It's represented by the integer number 97. Dec means decimal. HX stands for hexadecimal. Oct stands for octal. And then this is the HTML equivalent for those for the web developers out there. So as you can see, this is a list of some of the characters, and you see it's not every character, because there's special languages out there that there's languages that have special characters. So this list was not big enough to accommodate all the characters in every language. So that's why they invented Unicode. Unicode also supports things like emojis and things like that. So we have Unicode. See, you can represent emojis and stuff. Let me see. Is it going to show here? Just give it a minute. Yeah, so there's Unicode. So if you want to store a Unicode character, you have to prefix it with a \u to say that this is the Unicode. And we can do it in Java, right? We'll demonstrate it right now. I think you should be able, yeah, I think we should be able to show all of these characters. I just hope I'm gonna be able, I'll represent it in the right way. So let's say we want to output this, right? Let me see. Where is, let me see. Okay, let's say we want to output this one. Yeah, let's try to output this French fries, right? So I'm gonna say output this character. So it's always, remember, as there's the chart data type. So we use the chart data type to represent all the values in the ASCII table or in the Unicode table. So it's going to be prefixed with the \u. I think that it should be, yeah, invalid Unicode. Yeah. So it already picks up that I wanted to write Unicode. So 1F3 is going to be 1F. Come on, 1F3 5. I think, let me see, 1F3 5F. I think that should be it. Let me see. Does it want me to? Why is it doing this? I don't know. Why is it doing that? Let me see. Is it capital? No, it's not capital U. Okay, let me try this. It was working. I don't know why it's doing that now. Okay, let me do this instead. Let's say fries is equals to that. Why is it complaining with this? Okay, let me say 17. Let me output 1795. Let me say 1795. Let's try that instead. Remember, if you look at the ASCII table, this is 1795. Come on. Where's the character now? So there's the 1795, this one. I don't know why it's this website is not zooming in properly. So that's that special character. If you run it, there's the character here. You see that that's the benefits of using Unicode and things like that. So yeah, that's basically, you see this process of doing all of that. This is what we call decoding. Yeah, we decode it in such a way that it's in a human readable format. So you see that character is displaying the way we expected it to display. So yeah, I don't know why it's not output. It's not, doesn't want to output this, but it's fine. So yeah, that's bit of that's a bit about text format. So we have Unicode, which also includes things like emojis and stuff. And then ASCII only includes most of the characters on your keyboard. That's ASCII. Yeah, and digits and stuff. It's mostly your keyboard. And then Unicode includes more than that. It also supports languages, like the language that you speak, French, Italian, Tonga, whatever language it is, it supports it. Chinese, Mandarin, like everything, it supports everything. That's Unicode. And there's still space for them to add more. That's how big Unicode is. So mapping, so when you map, let me say encoding is a map, I think it's the other way around. Let me see. You encode is your mapping characters to numbers. Sorry for that, it's the other way around. Encoding, you're mapping a character to a specific number or to a specific format. You just say number. And then decoding is you're undoing that thing. So you're translating it from an integer back to its equivalent character. So that's how everything is stored on your computer. It uses numbers. It uses ASCII, but it actually uses Unicode. But yeah, it started with ASCII and then it evolved to Unicode. So yeah, that's why you're able to see emojis on your laptop and things like that. It's because thanks to Unicode. So we have all of this. So the problem with text files, binary files, I would say they are more efficient compared to text files because they don't involve encoding and decoding and translating and doing all of that, all of this and all of these things. It doesn't do that. That's binary format. Binary format, it basically means you so in a binary format basically means that you are literally storing the information in binary, which basically means zeros and ones. So there's no need of you translating and mapping values and encoding. You decode, you do all of that. You say, oh, okay, uppercase character A is the integer 65, and then from integer 65 you have to convert it to hexadecimal, because your computers usually use hexadecimal to represent the integer equivalent character, right? To represent all these characters usually uses hexadecimal. So you see that translation of encoding is going to start from A, it gets translated to 65, it gets translated to a hexadecimal, which is going to be prefixed with OX. So this whole translation it takes time. It makes the laptop, it's fine when you have small outputs. So for example, you're storing integer numbers from 1 to 10 in a file. You're storing them in a file. That's a very small file. Imagine you have 3 million or 300 million entries in your text file. So yeah, it becomes very slow because it's going to have to map every single character. So the T is going to be represented in its own integer number and then translate to its own equivalent hexadecimal value. And then the E is also going to be translated to a number, X to a number, T to a number. This space is going to be translated to a number. It becomes very cumbersome. So it becomes very tedious and time consuming. Yeah, so that's why binary file handling is more efficient than text files. because you just store it in the language that it speaks in, which is in binary. And then when you translate, you just translate it from binary to human readable format. So that's a bit about file handling. So let's explain how does file handling works. It's a bit like text files. So remember, with the text file, you use a scanner, right? And you say scan is equals to new scanner, and then you say new file, and then you specify the path here, whatever the path is, right? Why are we using the scanner? We're using the scanner because we want to scan the file and read from the file. So we're going to make use of the scanner class, which helps us to do that. But scanner can only deal with something that's in text format. So it's good with text files or a string or the standard input stream. It's good with all those things with text. But then when it comes to file handling, we have special classes for that. So remember, when you are reading input from the file, remember, not input from the file, input from the user, you use system.in, right? Which is the standard input stream, right? And then you use system.out, which is the standard output stream, to output data, right? Or information. And then this is to input or to read in data, right? That's how we do it, right? That's how it works. So it's the same way with file handling. If you are reading something from a file, we call that input. So it's input. The same way you read from the command line, and you use the .next int, next float, or .next functions inside your scanner class to read the input. So we're reading input. So we call that input, right? When you're getting something from that thing, we're getting information from the standard input stream or the console. So the same thing applies with files, but then now with files, remember we said input is part of the input stream, right? So it's going to be input stream like this. So we're going to reference the input stream, but the input stream that I'm working with is a special input stream. It's an input stream for handling files. So I'm going to use what we call a file input stream. And then for outputting to the file, we're gonna remember to when you're displaying something to the console, we call that output. So you usually reference the output stream, right? Because we wanted to output. Then we are not outputting to the console. Remember, we are dealing with file handling. So instead of just it being file output stream, it's going to be file just being output stream. It's going to be file output stream because we are dealing with files. We are handling files. So these are very important classes that we're going to work with. So when I deal with the file input stream and file output stream, right? So the problem with the file input stream, I'm going to introduce more data, right? So the file input stream, it acts like a scanner, right? It's used to scan the file. It's like a scan. It's like if you wanted to create the file input stream, right? I would say file, and then it says it goes to new file input stream, right? And then we take in the file handle. So just say new file, and then you pass in the path, right? It'll be like this, which is, if you look at the scanner, it's similar to the scanner. So, but then here we're dealing with files. So this one helps us to read from the file input stream, helps us to get input from the file stream or from the file. So we are reading input from the file. And remember, the data in the language, that the numbers are going to be stored in the information on the computer is going to be stored in terms of numbers. So since we are dealing with binary, it's literally going to be stored in binary. So since it's going to be stored in binary, it's going to be storing, you see the file input stream, right? It's going to store the information in terms of what you call bytes. And remember, a byte That's basically 8 bits. And remember what bit stands for. It's just an abbreviation for binary digits. And binary digits just means 2 binary digits, 0 and 1. So it's going to store it in terms of bytes. And remember, a byte is equals to 8 bits. Binary digits, 0 and 1. So basically, what do I mean by that? So let me show you how the process, what goes on behind the scenes, right? So let's say I wanted to, let's say this is me, right? I'm storing the character A into the file. So what would happen is it would translate this to an integer first, which is 65. And then you translate it again into binary, but like remember what I said? I said it's not actually gonna store it in, it is gonna store it in binary, but they usually use hexadecimal. I don't want to get into too much detail, but yeah, let's just say in binary, right? Which is basically zeros and ones, right? So if I do this, right? Let me do this. 65 in binary. In binary, so in binary it would be equivalent to this, right? So I'm gonna copy this. The prefix OB just means it's binary. It's a binary number. I don't need that prefix OB. I just want the actual number. So this will be the number. Let me count the bits. 1, 2, 3, 4, 5, 6, 7. It's supposed to be 8 bits because remember it's stored in terms of bytes. So you can, if it's missing, if it's not 8 bits, you can just add a 0 in front because it's not going to change anything. So this would be the binary representation of the character A. So this process that's taking place here, this process of translating from this to an integer, because remember it needs to look at the ASCII table. So the ASCII representation of 65 is the integer number 6. The ASCII representation or the integer representation of character A is the integer number 65. But then remember it doesn't use the decimal system. The computer uses the binary system, so it's gonna we need to also translate it back to zeros and ones, which is this. So inside your file or inside your operating system, it's going to be stored in terms of zeros and ones. But then just save this. But then remember, it's storing it in terms of bytes, right? That's I'm going to raise another issue with this file input stream class. The file input stream class, it can only store you can only store it in terms of bytes. The maximum is a byte because the information on the computer is stored in terms of bytes, right? So it only makes sense for you to store information in a file, to store information in binary, and the maximum that can be stored is a byte. It only makes sense because the information on the information that's stored inside your operating system is in terms of bytes. So let's create a file input. Let's output to the file, right? Okay, so to output to the file, to read input from the file, right? You can use the .read function. There's a read function, so you'd say the name of the file input stream .read to read the information, and then with the file output stream, you can say file .write to the file. These are the functions that you use. Read to read because you're reading from the file, and then write to the file because you're writing to the file. And then you pass the byte here. But then in your Java documentation, they actually store it in terms of integers. So the max out, it's not really integer because it's gonna cast it to a byte. But yeah, let's not get into all the subtle details because it's gonna make the video longer. So file output, right? Then I'm gonna call it f out equals to new file output stream. and it takes in a file handle, new file. Remember the benefits of the file class. The file class helps us to helps the computer, or it helps us to tell the computer that, listen, this is an actual file. It's not the string. So that we remember, whenever we creating a file, we need to specify the path. Specify the path, and okay, it's gonna throw a file not found exception. Okay, there we go. Because we might not find the file. I just forgot to edit in a try catch. So let's specify the location where we want to store this information. So I'm gonna say source folder, and then within that source folder, create a file named let me just name it output. And remember, if you check your slides and your textbook, they did say in what extension they usually use to save the file. They usually use the dat extension. Yeah, I think it's the dat. Yeah, the dat extension. Oh, is it? Yeah, I think it's dat. Yeah, yeah. Output.dat. They use that extension to store to say that it's in binary, to store binary information in binary, in a binary file. When you see the extension .dat, it means okay, it's in binary. So how do we now write to the file? It's simple. Let's say I wanted to write the integer number. Let's say I wanted to write, okay, I didn't spell it correct. Let's say I wanted to write, remember the maximum you can store this file output stream, you can only store a maximum of a byte. And a byte, remember, is equals to 8 bits. And to find the maximum number, you say 2 to the power of number of bits, which is, in this case, it's 8 minus 1, which is 7. So maximum number you can represent is 2 to the power of 7 and minus 1 there. That's the maximum, which is 2. Is it what? I think it's 25. Is it 255? If I'm not mistaken, I think it's 255. Yeah, 255. So basically, the maximum value you can store is the integer number 255. And the problem is with the file output stream and the file input stream, you cannot read and write primitive types. So that means you're only dealing with the byte. So that's the problem. We'll get to how Java handles that case. So I would say f out dot write. You see, it takes in a byte. I don't know. Yeah, I saw this one with, it specifies the byte, whatever. Yeah. So I want to write it. I want to write a value to the file, right? Let's say I want to write 100. So I'll do that. But then, okay, why is it doing this? Okay, let me try something. Why is it? It just complains for no reason. Okay, it's not that. Oh, it's the IO. Let me say add exception to existing. Oh, it wanted me. Okay, let me see. Oh yeah, I remember. So yeah, it also throws an input output exception. So I suggest you just, instead of saying file not found, just say IO with IO exception. Just say it throws an IO exception, because when you're trying to write, you might fail to write to the file, right? And don't forget your finally block. So remember, the finally block means final. It means regardless whether this thing, the try block executes or not, this finally block will always be executed. So I need to close. So I need to say f out dot, okay, it's not visible. So since it's not visible, I need to declare it outside of my try. Then let's just set it to now. Then I'm going to say f out. But then I don't want it to throw a null pointer exception. I'm going to check if the f out object is not equals to null before I close it. And then f out dot close. And it's gonna throw an exception. Yeah, there's a lot. So okay, let's just do it like this. Don't check, because with binary file handling, it doesn't matter whether you say it's not equals to now, you still need to catch the exception. So just know in this finally block, you're gonna have a try catch, because there might be an issue with closing. So you need to handle that exception, which is an input output or IO exception, EX, and then EX dot print stack trace. So there's the code. You can that's why it's important to use automatic resource management, because you wouldn't have to write all of this. So there's our code to write to the file. It's going to write the integer 100 to the file. Of course, it's not going to display anything because it's not, there's no output. I didn't say system.out. But if I refresh here, there should be a file. Let me refresh and then go inside. There it is. There's the file there. It has been created. And then there's the number. So as you can see, look at this interesting thing here. It's stored the letter D and it's in binary. You see, this is the binary format. So the computer does know. For you, it might looks so bizarre. You're like, okay, what does that mean? But to the computer, it's like, oh, D, I know. That means it's an integer number 100. So that's binary and file handling for you. Just give me a sec. I want to open the, okay, no, not there. So I want to open home. Nope. Or other location. So where's the Eclipse workspace? Is it under documents? Why is it not showing my workspace? Okay, let me check. It's the okay, source. Where is it? Why is it not showing now? Okay, it is there. Just, yeah, I'm a bit blind. So there's the source folder, right? There's the file. If you open this file in a text editor, right, you see it has the character, the letter D. The computer knows, because it's in the language of the computer. The computer knows what D means. D to it is like, oh, that's 100. That's the integer number 100. But yeah, that's binary. It doesn't have to deal with this thing or these nuances of translating from character to an integer and then to a binary and then decoding it again from binary to an integer. Because if you write this, after this translation, right, this would be the encoding part. The decoding part, it means it goes vice versa, starting from the binary to the integer number to the character A. That's why when you open any file saved as .txt, it's going to show you characters. So the moment you click in that file and you're opening it, I'll put it in simple terms. It's translating all the zeros and the binary and everything to text so that you can, because you've saved it with the .txt extension. So when it's doing that, it's decoding. So yeah, translating from machine language to human readable language or format, that will be decoding. When you're translating it from the human readable language to the binary language or to the binary form, that would be encoding. So that's the nice thing about binary files. You don't have to go through all of that. You just save everything as binary and then convert it to binary. So I would say that to some extent, the binary files, right? It doesn't include the middle part. It just It just goes from the character itself to the binary, and then from binary to the character. It's not necessarily like that, but you just view it like that. And another thing about binary file handling, right? It's efficient. It's cool. It's good. It's way better than text files. Then another benefit of file handling is or I wouldn't say a benefit, but you don't just view it like this. If you saw here, I just double clicked and I really can't read the file. In this scenario, it's straightforward because it's just the integer, it's just the letter D. So let me write something else here. Let me say f dot write. Let me say 25, right? Let's write integer number 25 also to the file. And then I've run my program, and then I'm gonna refresh. I'm gonna go back, and then I'm gonna open, then open the file again. And then click OK. Wait, what's going on? Why is it saying it's I don't know why it's doing that now. Okay, let me open it with Notepad plus plus. Is so it's actually because because the D it's sort of like text, so it was assuming that it's text, but it's not really text. So they can see it's DEM. You don't understand this language, but the computer is like awesome. I mean, this understand. It knows, okay, this is the integer 100 followed by the number 25, another integer 25. So that's binary files for you. It's stored in binary language. So since talking about that, the maximum you can store is a byte. So now how do we store primitive types? So there's this class named data for dealing with such scenarios. There's this class called for reading input primitive types. You use the data input stream. Then for writing primitive types to a binary file, you use data output stream. So far this is what we have, right? If I go to my diagram, so far this is what I have. I have the file here. You can just say that's the file there. So let's say this is the file. That's the file we're making the changes to. And then I have the file input stream, right? Class. This could be the file. Yeah, this could be the file input stream of output stream. Could be either it can be any of them. This is how it's gonna work. It's gonna go from okay. Because from read, if you wanna read from the binary file, this is the file, right? It gets transferred through the file input stream, and then the file input stream is gonna have the information in a human readable format or human readable language. But then the file input is related to a byte. So how primitive type? To store primitives, we would also have to pass that file input stream through what we call the data input stream. The data input stream class helps us to be able to read primitive types. And then the data output stream help us to be able to write to be able to write primitive types to a binary file. So zoom out a bit. Okay. So we have from the file, it gets passed to the file input stream class. Remember, the file class, its purpose is to handle the things the issues about different operating systems. Is a D drive, F drive, some drive. On the Linux or Unix, right? The forward slashes. So, okay, let me connect my charge. I wasn't paying attention to the battery level. So, wait. So, like I said, the file class doesn't have methods for reading and writing to a file, whether it's a text file or a binary file. That's why we have these special classes that handle that. The problem with the file input stream class, or like I said, it only makes of a byte. You cannot store primitive you cannot read primitive types from a file. You'd have to pass the file input stream through a class named data input stream. And data do, right? Data input stream the same way as a text file. Remember, text file, if I stored these numbers, 1, 2, 3, 4, 5, 6, 7, right? So that let's say that's the information inside of my text file. Inside of this text file, inside of this file, right? Let me not say text file. Let's say, okay, let me do this. So these are the integers, right? Let's say these are the numbers, right? It's just numbers. Remember, it's binary. We're talking about binary files here, but that just doesn't really matter. I just want to get this point across. So what data input stream does, it works the same way as a scanner. So to read each value, it's going to read one value at a time. And there's methods within the data input stream class to call one value at a time. In this case, we have integers. So I can be able to read one int at a time, read the next int, read the next integer. But then developers, they realize that when you have to read one piece of information at a time, it's going to make your application slow. So instead, what they do is before they read the information that was stored as primitive types, they pass it through what we call a buffer. So a buffer basically means that instead of you reading the piece of information one at a time, you store all of it, you read the whole chunk and store it into something called a buffer. So you can view a buffer as like this thing here. This would be the buffer. So it's going to be passed through this thing called a buffer. It makes and this is what we're going to call a buffer. But since we're dealing with the input stream, it's going to be called the buffer stream because we are dealing with input in this scenario, right? Make the text a bit bigger and then change this to orange. So it'll be passed through the buffer. And then what the buffer does, right, instead of reading it one at a time, it takes the whole chunk and stores it here. So it's like the whole chunk is placed here it's like sort of like a waiting area. Okay. I don't know why it's doing that. So let me just do this. And then enlarge. Then, yeah, so it takes the whole chunk and then stores it there. Instead of taking file one at a time. like the buffer, it gets so we take and store the whole chunk inside that tunnel, and then instead of going back and forth to the file, taking from the file, bringing back the information, going back and taking from the file, that's going to make the process of reading and writing very slow. The buffer is passed through what we call a buffer, which in the buffer, what it does, it takes the whole chunk. So it literally takes everything in the file and then it places there. And then now, instead of you going back and reading one piece of data or one int or one string or one char at a time, you just read the whole thing from the file and store it inside. It's like a waiting area or something like that. It just takes the whole chunk, or the whole file, everything in the file, puts it there. Then you can take from this buffer one at a time. It's actually way faster. It's just that you won't see differences because you're working with small files. The bigger the file you see, the bigger you see, the more important you see, the more important the buffer is. So this is the process that we're going to be dealing with. We're going to have the file, and then from file we pass it through the file input stream. Remember, the file input stream can only store a max of a byte. It cannot represent primitive types. So we have to pass it through input stream class, which is the class that helps to be able to types. But then this thing of passing it directly, one piece of information at a time, going back to the one piece of information, the file handling, binary file is going to make the binary file handling very slow. So we would have to introduce a class in the middleman who's going to take the whole chunk from the file that we have, the whole chunk, store it inside the buffer, and then instead of the user reading, instead of reading from the file, we read from the buffer. And to write to the file, it's basically the same process. The only difference is the direction of the arrows. So it can be like this, and the class is used. That's the only difference. So I'm going to delete this arrow, and then now instead of going that side, it's going this way. Passed to the buffer. Come on. And then you pass it to the file output. I'll rename this classes soon, and then you save it to the file. So since we are writing to the file, we call that output file. So I'm going to use the data output stream. Then I'm going to pass it via the buffer output stream. So it as a chunk, and then save it as a chunk, as a whole chunk inside the file. And then file output stream. We're outputting to the file. So you get there's two. Let me just zoom in like this. So if I'm right, this is how it works. You pass it through file stream class to create an instance of file input, or you just pass it through the file input stream class, right? After passing it through the file input stream class, you have to pass it to the buffer so that we read in the whole chunk instead of reading one piece of information at a time from the file. The same thing as when you're writing to the file. We don't write one thing at a time. We write the whole chunk to the file. So this is basic with this is what we'll be doing with the classes that we're going to be using when we're reading and writing to the binary file. So let's start. Right. There was a lot of explaining. So let's start. Let's look at. Let me open. There's the source. So I'm going to copy everything out, everything except for the bin and source. I'm going to copy docs and data. So copy go inside here and then click on my project name, or right click and then press what is that? Okay, it's not showing. But yeah, I just wanted to paste. So it should show on your Windows operating system. So I'm just going to press Control V to paste. Then I've pasted. So there's the files. As you can see, .dat. That's how it's represent a binary file. So we have all of this. So let's let's start doing the question. Let's get to the important. So let's see. So it's going to be stored inside this in this format, right? Before, okay, it's fine. It's fine. We'll get to that one once. So I don't need this. I'll need it, but not now. Let me remove all these imports, and then also delete this output.dat file. So let's there's the file, right? So we're gonna have item count, the first thing, and then I have the player ID, player role, player prowess, player man, and stuff. So that's yeah, they pretty much explained everything. So I'm assuming we're gonna have a class. Okay, so let's see. Majors of the beach require conversion of these files into a new binary file format that uses Java objects instead. Additionally, they require contents of the file to be sorted correctly. Comparison between two player instances can be done firstly by comparing their prowess. So the compare function we're gonna use is gonna compare based on the prowess. So we'll get to that. Then if those are equal, comparing their men, if those are equal, then if those are equal, comparing their men, what they're talking about. For the problem stated above, create a Java project that contains the following. A class, create the player class that stores the required data, implement the correct interface for serialization and blah, blah, blah. The class must be placed inside. So we are doing two things, doing binary, doing file handling. So I'm going to copy these packages, right, and create them. So I'm going to right click, say new, create a new package, paste the name there. And please don't select create package info to Java. That's going to make your code crash. Because what it means that now whenever you add or create a new class, you're going to need to update this package info to Java, of which they didn't teach you about that. So don't, if it's selected, it might be selected by default. Just unselect it and then click finish. And then we're going to paper, create the other package. So argc.csv2a.fantasy.file. Open it and then say new. No, inside under source new, and then edge place and click finish. So we have I'm just going to remove this main class here. We're done creating our classes of our two classes. We're going to need the player class and the player file. So one thing at a time, right? So what I'm going to do is I'm going to create the player class first, and it's inside the model package, fantasy.model. So I'm going to go to Eclipse, fantasy.model, select it, and then right click and click on new. Then after new, I click class. And then I'm going to paste the name of the class. And then, yeah, that's pretty much all I have to do. Just provide the name there and then click finish. And then let me just create the player file handler. I'll add the information when I have to, when I'm there. So go to the fantasy.file, create a new class, and then edit and click finish. We'll get to do all those other things later. The file we'll get to file handler later. Once we're doing the question. Let me see. Okay, it's been an hour. Roughly about an hour to finish it. So let's see. We have the player class that we need to create. Yeah. Compared to operations, blah blah blah. Okay. So let's scroll up. So remember the player class. If you want to know what information needs to be inside the player class, look at what they told you. They said the company majors of the beach need to automate the processing of player data. So this is player data, meaning this is information that represents for each player. So this and they even give you the data type. So this is the information that we're gonna have to store for each player inside the player class. So we have item count, which is of type int. I'm gonna use you see this information, all of the information here, explanations here. I'm gonna use it for my Java doc. So we're gonna have item count. Remember, you need to explicitly make it private because by default it's not private. It's if you just make a variable and you say item count like this, right? But this does it's a access what is this access modifier, right? Its access modifier is gonna be of type package, which means that anything within the same package is this class, which is the xc.csc2a.fantasy.model. Any class within this same package that this class is in has a variable. So we don't want that. So that's why I'm saying you'd have to explicitly make it private. So you have to say private item count. Then this, I'm just gonna say these are my instance. Okay, I just want Java doc. These are my instance variables. I'm calling them instance variables because these variables, they're part of each instance, depend on the instance, right? They're called instance variables because they depend on the instance. They're part of each instance of this class. So ID, unique player ID. I'm just going to call it player ID, the variable. It's a player ID. So we're going to have private string player ID. Then we are done the role of the player, which is, so I'm gonna private string represents the role for the player, and then prowess of the player, which is an int. So private int prowess. And then the manner of the player, which is a double. Private manner. And then now I need to create my accessors and getters and the constructor. So after here, I'm gonna create. I'm just gonna create a parameter less constructor. And it needs to be Java doc, so I need to add to. So parameterless constructor, so public player takes in no parameter, hence parameterless constructor. And then I just initialize my variables. That's all I'm going to do. So remember, in Java, right, every class that you have, if it doesn't extend or inherit from another class, by default it inherits from the object class. Because remember, when you talked about in the introduction video that I talked about, when I talked about Java uses, it's an object-oriented programming language. So everything needs to be placed inside of it needs to be represented in terms of an object. So that means everything needs to be inside of a class. Even the main function needs to be within a class, because Java works with objects. So since this class by default, let me show you, when you create a new class, it does tell you though. Look at the where it says superclass. It tells you base class of that class that you're about to create. It's always object. If you don't specify that it extends another class, it's always object. So since it's always object, and by default in Java, for the constructor that you have, or any constructor that you've created, by default it calls the constructor of the superclass before it executes anything within any code part of your the constructor of the class. So me, instead of waiting for it to call it automatically, I will explicitly call it. Remember what I said, if you don't say extends to say that it inherits from another class, by default it inherits from object. This class, it inherits from object. I can just say super and call the constructor of the superclass. So the super keyword, it's used to refer to your superclass. And let's see, look, it tells me what the superclass is. It's the object superclass. It constructs a new object. So this is the super keyword is used to refer to the superclass or your base class or your parent class. There's different terms. Java uses the term superclass. So when this keyword super is accompanied with the round brackets, it refers to the constructor of the superclass. If the super keyword is used and use a dot like this, it's referred to the superclass's methods and usually methods, because we know how to design classes. We design classes by making all the instance variables private. So use the keyword and the word super followed by a dot, you are referring to the methods inside of your superclass. Then there's this keyword. When you use this with brackets like that, it's referring to this current class's constructor. So you're calling the player constructor within the class itself. So you're calling this class's constructor when you write it like this. But when you refer to this, when you use this keyword followed by a dot, you are referring to the member variables or the member methods or the methods within the class. This keyword just means this class. So when you use this, it means this class's methods or this class's instance variables. Or yeah, and you followed by a dot. If you use this keyword accompanied with round brackets like this, it means this class's constructor. In this case, in this scenario, I didn't put any parameter, so this will refer to this class's default constructor or parameterless constructor. So just know those differences. So one thing about classes, right, in Java, if you create when you create variables inside of a class in Java, by default, it initializes every instance variable to its default value. So I don't really have to come here and say this dot item count is equals to 0. Java will do that for me. I really don't have to do that. So I'm just going to leave it empty. I'm just going to call my superclasses constructor. And then I'm going to create a parameterized, since it's a parameterized constructor, I'll put javadoc after information. So I'm going to have item count, and then I'm going to have string player ID, then comma. There's no space anymore, so that's why I'm doing that. I want my screen to go to that other side to be too long. I don't want the text to disappear. Let me see, but I think the role can still fit. Let me see string role, right? Yeah, the role. You can see the role, and then here I'm gonna come and say int press, and then double n. Then remember, whatever constructor you're using, it's gonna call your base class or your superclass's constructor. So by default, the first keyword, the first thing that's going to be executed underneath your constructor is an invocation or a call to the constructor of your. So me, I'll explicitly call my constructor to my superclass before I do anything, because that's how Java is gonna do everything. And then I initialize my variables, right? Then this dot player ID equals to player ID. And then this dot role is equal to the role from the constructor, and then this dot prowess is equals to prowess, and this dot manner equals to manner. Then remember what I was talking about, the descriptions of these variables, right? They're in the document itself, the PDF. So I'm just going to copy it so that I have at least some comments in my Java doc. So this is the number of players in the file. Then the unique player ID of the player. And then the role of the player. The role of the player. And I'm sure that's going to be the prowess of the player. I don't want to waste time typing. I'm just going to copy and paste. Then manner of the player. So this is going to be the manner of the player. So this calls my super class, which is the object class. Since I do not have an extends keyword here, so by default it's only going to extend from the object class. So there's my code, and then now we need to generate the accessors and getters and stuff, right? So for the sake of saving time, I'm not going to type it all out. I'm just going to right click, and then I'll go under source, and then I'm going to say generate getters and setters. And then I'm going to select the instance variables that I want you to generate the getters and setters for. And then I'm just going to say generate, and then done. Now I just need to add javadoc. So here I'm just going to do this, and here I'm going to do that, and there I'm going to do that. Yeah, I'm going to do this. Here I'm going to do that. And there I'm going to do this. I'm going to do that. And then do this. And then do that. So yeah, they wanted to add comments. Let me see. So let me just returns item count, which is the number of players. And then this is just number of players. I want my Java doc not to be empty. Then I think and then this. And then the role of the player. Get role, this returns the role, which is the role of the player. And here is just the role, which means the role of the player. Okay. And the prowess, which is the prowess of the player. Set the prowess, which is the prowess of the player. Then I need to take the mana there. Comment for mana. Return mana, which is the mana of the player. Mana, which is the mana of the player. So we have this is straightforward. This is accessors and mutators. As I assume you're familiar with accessors and mutators. So let's see. So another important thing that we need to talk about is this part that says serialization and comparable interface. Let's talk about binary file handling. So by default objects, right, cannot be stored or saved binary file. So in order for you to save them to a binary file, you would have to, in order to save them to a binary file, you would have to mark the class as serializable. Meaning, remember, serializable just means that the object can be written to a binary file. Can be written and read to or from binary file. So by default, objects, they can't be stored to a binary file. So since they can't, you have to add you have to mark the class as serializable. Why serializable? Because in stored in a binary file as serialized. Information that's stored into a binary can be referred to as serialized, right? So if it's serialized, that means that thing needs to be serializable. So that means I have to implement this part. When I say mark, just means I have to implement the interface called serializable. So the interface serializable, it actually doesn't have any functions or constants. So it's basically like this: is public interface serializable, right? Like this. That's the interface. It's just empty. What this in any empty interface, we call that a marker interface. So a marker, we can just say it's a marker or some label, so that they know, so that the Java virtual machine or the computer knows that this thing is serializable, and it can be serializable. That means it can be stored to a file, or to a binary file, specifically a binary file. If you don't add this label or this mark, then it's going to fail to serialize it, or to write it to a binary file. It's going to fail. So you need to add that serializable, implement the interface serializable, which in turn makes a marker or puts a label on the class to say, okay, any instance of this class will be allowed to be serialized to a binary file, or saved and read from a binary file. That's all it does. It just serves as a marker or a label to say, okay, this thing belongs to this. So for example, it's like, imagine imagine, what is this? What is this? I forgot what that company is, but there's a company that inspects food, right, to make sure that you are allowed, this food can be consumed, and they put a marker on the food item to say, okay, this food is not harmful, it is good, it can be consumed. So it's sort of something like that puts a label, an icon, or a tick that says, listen, there's any objects or any instances of this class, they can be written and read to or from a binary file. That's all it means. And if you, in order for you to read and write to a binary file, you'd have to implement serializable. As long as you don't implement serializable interface, it's not gonna store the object. That's the problem. So yeah. So you won't be able to store anything related to that object to a binary file, whether it's the primitive data type, or the primitive information, or the whole object itself. It's not gonna work in binary file. You'd have to make it serializable. So let's go back here and tell the compute. So I'm gonna say implement serializable. I think it should be fine. Yeah, there we go. There's a serializable, which just means, let me see if there's notes here. Serializability of a class is enabled by the class implementing the interface. Class do not implement this interface, or classes that do not implement this interface will not have any of their state serialized. So serialized meaning that it's written to a binary file. Deserialized meaning that it's read from a binary file. So it even tells you in the notes here that classes that do not implement this, you cannot save their state. Their state is basically the information, the current information for each instance, whether it's the item count or the role or the prowess or the manner, whatever the state is, you cannot save it unless you make the class serializable. We also have something that we need to implement here. There's an interface we need to implement. Remember, they said the class that stores the required data implements the correct interface for serialization and comparable interface. So with that being said, we need to implement the comparable interface. You can see it's using generics, right? Remember, this class, it's not going to be a class that takes in any generics. Generics, I think, should be question. Is it question 1? Okay, it's not. Let me see. So comparable, yeah. So let's read. Where's this part? Where's the part that talks about? Okay, there it is. So you see, additionally, they require the contents of the player file to be sorted correctly. Comparison between two player instances can be done by firstly comparing their prowess, right? So I need to specify their prowess. Then if those are equal, comparing their mana. Okay. So we need to actually compare. We need the ability to compare two objects. So how do we tell Java that we want to be able to compare two instances of that class? We implement, they even tell you, we implement the interface called comparable. So if we look at here, if you look at this, if you look at here, they said we should be able to compare the prowess. The prowess meaning integer value here. So what I'll do for now, if you remember, we're already implementing serializable. If you want to implement more than one interface, it's separated with the comma. You put a comma there, and then you specify the next interface that you want to implement. So I want to implement comparable. Then let me just. They really didn't talk about. Let's see. Let's scroll down. Really didn't talk about they really didn't talk about what is this, generics here. So let's see, because we're supposed to it cannot be parameterized. Let me do this. And then add unimplemented methods. There we go. So the compare to, right? You implement in order to compare objects. Remember everything. Remember Java is object oriented. So everything is an object by default. So to compare objects, you'd have to implement the comparable interface. And in this scenario, the data type that you pass is the things that you want to compare. If you want to compare two integers, you'd pass the integer data type or the integer class between the greater than and less than symbol. Or if you want to compare strings, you'd say, I want to compare strings. You do that, right? But then in our case, we want to compare players. We want to compare players. So I'll put the player, the name of the to say, okay, listen, this class that I'm creating is comparable. That means you can compare. It's comparable, and each thing should be compared should be each object or each instance of this class, which is the player class, because it says here, if you scroll up, player instances can be comparison between two player instances. Player instances. So that means the type I must pass is player. And there's another, the comparable interface does have one function, is the compare to, of which you must override. There's the compare to, we'll implement just now. So the comparable, after implementing comparable interface, that means the objects are comparable. That means you can compare. So there's three things that you can do. Or you can clone. So they might in the semester test say, okay, these objects can be cloned. When they say they can be cloned, you'd have to implement the interface called clonable. That's all you have to do. And what this means, it means that you can call the clone method an instance. Clone means that clone, make a copy. So what it means. So they could add that. For the sake of simplicity and not making this video long, I'm just gonna remove that. In the next paper that I'm do, past paper that I'll make comparable. The clonable interface is also a marker. It's empty. It's okay. It's not really empty. Marker interface because it just marks and tells Java, okay, listen, this class is clonable. You can make clones. So we scroll down, we go to compare to. So how does the compare to? So the compare to function, it works in this way. You have, if the left object is greater than right object, or the object on the right, or that value, let me not say object, let me say left value is greater than right value, then the answer that will be returned is 1. If if left value is less than right value, the value that should be returned is -1. And then if left value is indeed equal to the right value, if they're equal, then you should return 0. So that's how the compare to function works. This is how it works for numeric data types. Things, it's kind of different, the values that it returns. So, but for this, we're just gonna, for numeric values, it returns 1, -1, and 0. So let's go and compare. And let's see what we were supposed to compare. So we're supposed to compare their prowess. So let's compare their prowess. So I'm gonna compare their, let's see. These are simple if statements. I'm gonna say if O, let me not call it O, let me say other, the other object, right? If this object, this object's prowess dot prowess okay, this is public. So let me just say this the get prowess. Let me use the access. If this prowess is less than the other object's prowess dot get prowess, then it should return -1, right? That's what we said. And remember, the object can be one of these three. It can be one of these three things. The objects, one object can be less than the other object, or the not the object. The prowess can be less than the other prowess, or it can be greater, or they can be equal. There's no way they can have all the same values at the same time. There's no way it can be greater, equal, and less than to the other prowess at the same time. So that's why I'm gonna use an else if. Because if I have else and then else if, that means only one of these conditions is true. So this dot get prowess again is greater than the other dot get prowess, then you should return, if it's greater, that means you should return 1. And then the last one, else if this dot get prowess is equals to other dot get prowess, then you should return 0. And then you are done. You can compare, you can call this compare to function to compare the objects. So these people, they were not playing around in the semester test. So I'm just thinking about something. We are not done with the compare to function. Listen to what they're saying here. Comparison between two player instances can be done firstly by comparing their prowess. Then if those are equal, so that means under the if statement where these prowesses are equal, we should also compare the men. So yeah, it's gonna be quite a long implementation, but let's do it. So remember, if you have more than one statement and an if statement, you'd have to add curly braces. Here, if they said if they're equal, we are not done comparing. I shouldn't return yet. Compare again. But now I'm going to compare their manner. So let me compare their manner. So I'm going to say if this dot get manner is less than the other object manner dot get manner, then return -1. Then else if this dot get manner is greater than the other dot get manner, and return 1. And then else if this dot get manner is equals to other dot get manner, then return 0. At least one of the statements has to be true. Okay, this thing is compared to. Okay, let me do it like this. Because I don't want to remember what it. Okay, it's fine though. It's fine. I can just leave it like this because one of these is going to be true. One of them is going to be true. So that means we'll never reach this return 0. But then Java and other languages, but mostly Java, it's going to puts in this return 0 as a safety net. Just in case if any of these don't execute, you should be able to return something. Because what if, that's what it thinks, right? Remember, it doesn't know your problem statement. It doesn't know the problem or the practical that you're solving. It knows nothing about it. So we are done. This is the implementation for the compare to. So yeah, we are done with this class. Now we should go to the player file handler class. So the class has the following static methods, right? So let's create the static methods, right? So this is the actual reading and writing part. So I need to copy this information, go there, and then save, and then open the file handler class. So there's the file handler class. Let's create our methods, right? So public, I saw that it's supposed to be static. So I'm going to put static there. So remember static meaning that it's shared. Then I'm going to put question mark here because I don't know what's going to return at the moment. I haven't read that part. And then the name of the function. The parameter, I'm not sure. It could be a string or a file handle. So I need to read the question. So the method accepts a file handle. So the way I view this question, right, to make things simple for myself, when they say file handle, they're literally meaning the data type is file, and then the name, you can just name it handle. So what I like to do is just, I like to copy all of this, then paste it here, like that. And then let's go to this and returns a list of players right from the file. So it's going to be a list of players that must be returned. So I'm going to come here and say list of players. So I need to import everything. So let me start by importing the list, and then import the player class, import the file class, and then it expects me to return something. For now, I'm just going to return now. So yeah, there's the code, this is the function. Let's create the other one before we start implementing. So read, this is meant to read from the file. And then write player object, that's the name. And it's exactly the same as the previous. It returns an array list. Oh no, it doesn't return. Okay, yeah, we should be careful. It accepts two things, file handle and the list. So that means it doesn't return anything. It's gonna be void. public static void their object. They said it takes in a file handle and a list of players. So player, and then I'm gonna call the variable players. So there's the code, there's the function. So we have our information here. We have our two functions, and writes the player as objects to the file. I don't know who made this lecture angry, but yeah, they wanted you to write everything. So in the first, when you're reading, you had to use data input stream. When you're writing, you had to use object output stream. If you didn't know those differences, it's shy for you. So let's read from the file. Let's start with reading from the file, right? Let me close this. Where's the okay, let me just save this just in case you guys need it. So let me save the image as a PNG and then save it to, let me just say download, and then yeah, there's the image. It's fine. So let's read from the file. Yeah, and this paper is not playing around. So let me add, what is this? Javadoc. So let me add Javadoc. I don't know what to name it. I'm just gonna say file handle and then return a list of players. And then here I'm gonna need Javadoc again. And then I'm gonna say this is a file handle, and then this list of players. Then yeah, we're good to go. Let's read from the file, right? So remember this class is supposed to, this function is supposed to return a list of players. So that means I must create a temporary variable called list of player, and I'm gonna call it players. And I noticed something, right, with your past papers. Be careful what they say. When they say a list, they mean a list. When they say an array list, they mean an array list. Remember, a list is an array list is actually a subclass of list. So just know the differences. They will tell you if they want an array list. I think I've been making that mistake of using array list, but yeah, you shouldn't use array list. They said list. And then you're gonna say new instantiated. Remember, list is a class. You'd have to instantiate it. So I'm gonna say new list, then oh no, it's wait. It's not a class. My bad. It's yeah, it's an interface. Yeah, it's an interface. Let me do this. Yeah, it's an interface. My bad. It's an interface. So yeah, so it's an interface. The array list actually inherits from this class. So since we are not gonna do, it actually makes sense. Remember, since we're not gonna be, what is this? Let me see. How are we going to, let me check something here. Because this is an interface. Okay, it's fine. So since we're not gonna be doing anything to each information that we're gonna add to the list, we're not gonna be calculating many things, adding, getting, all those things. We're just gonna add and get. That's it. We're not gonna do many operations. So it's good to use a list. So we're just gonna use the list, and then at the end of the day, we need to return the list. Okay, I'm just gonna initialize it to now because it's complaining that I didn't initialize it. But then it's a list. How am I supposed to initialize it? So let me see. Okay, you can, I think Let me see. Will this work? Because I remember there's a function here. Yeah, you can. Oh, yeah, you can just return this. You can just use this. You can just call the off function to create an empty list, to initialize it. Basically, you can just say list.off, because I think I once did list. I think that's this the function that you use to initialize it. So remember, so basically with array list, you'd use an array list if you want to make changes to the objects, to the instances, and all those things. Here we don't want to make any changes. We don't want to do any of those things. I just want to create a list that's unmodifiable. You can't modify it. Let me see. Yeah, I think you shouldn't be able to modify. Let's see. Let's see. Let's go to the question paper. So read player data method accepts a file handle as a parameter and returns a list of players read from the file. So the file is stored in what format? This is the data format. So the first thing that's stored is the item count, which is the integer. So yeah, I'm gonna read it in this exact order. That's how I'm gonna read it from the file. So remember, we need to have a try catch block, and then I'm gonna have catch. Then I'm gonna catch an IO exception, input output exception, and then import. Did it import? Okay, it's complaining because it doesn't know why am I. It doesn't have. There's no line. There's no line in the try block that raises this exception. So I'm gonna create. I'm gonna use automatic resource management. I think that's what they said. Let me see. Yeah, ARM. So you need to use automatic resource management. Remember, automatic resource management helps. It was invented for developers because most developers, whenever they're doing file handling, they forget to close the file. So it automatically closes the file if you use automatic resource management. So remember the image that I was talking about. We start, since I'm reading from the file, I'm going to use file input stream. So file input stream, I'm going to say fin, or for file input, new file input stream, like this. And then I'm going to pass in a new file. Okay, there's the file handle. I'm passing it as a parameter, so I'm just going to say file handle there. Then import, and then I'm going to also initialize a buffer input stream. Buffer in, right? So it goes to new buffer input stream, which takes in that file input stream. I think I need to add semicolon there. Terminated. No, it's buffered. Buffer. It's buffered input stream, and import, and then semicolon there, and then I'm gonna have the last one. If I look at now, the question is, remember, I have to pass it in a buffer to store it as a whole block of information instead of reading one piece of data at a time. So if you look at the format that this file is stored in, it's stored in what format? It's stored in terms of what is this? In terms of data, right? Data is in binary format. First int indicates an item count. So here, lucky enough, we don't have things like inheritance and stuff. So this is what we have. So I don't know how many instances are there. That's the thing. And I think that's why they created a list. So let me open one of the files. okay, it's not really cancel. Yeah, it doesn't, you can't really tell. Let me just close. It's difficult to tell. Let me, okay, not this. Let me go to my downloads. Okay, it's not there. It's under Home, Eclipse Workspace, Data. Let's look at the large file. I want to open it with what is this? Notepad++. I hope it should be able to display most of the information. Yeah. So this is a pretty large file. Yeah, that's just what I need. So in file handling, right, there's a, how do we, in binary file handling, right, how do we know that we've reached the end of the file? When we see -1, right, but we'll get there. Let me continue, let me do this. So since we are reading in this format, they didn't say it's an object format. This is the format that it is in. So that means we're going to use the data input stream. So we're reading data. If they had said it's object 1, object 2, object 3, then we'd be using object input stream because we are reading objects. In this case, we're reading data, and it's even written data file. There's player data, not player objects. So I'm going to read it like that. So I'm going to use the data input stream input because I want to get input. So I'm just going to say data in. The data input is equals to new data input stream, which takes in the buffer. Because remember, in order for us to, before we use the data input stream, we need to pass the information via the buffer or through the buffer so that it's stored as a block, and then we just read from the buffer. That's why I'm passing the buffer, because we're reading the data from the buffer instead of reading the data from the file one at a time. So to get, let me see, I think it should be there. The function should be inside. So data input dot read. So what I'm going to do is I'm going to use the read function. Okay, yeah, I'm going to use the read function. It reads the next byte of data. It returns -1 when there's no value, there's no data left. So if no byte is available because the end of the stream has been reached, the value -1 is returned. So I think I'll use this one. Yeah, I think I'll use this one. So I'm gonna say while, and then I say data input dot read. I think it should be fine. If I say that read is greater, will that? Yeah, I think it should be fine, because that's how you'd read multiple. That's how you'd read multiple data from the file. So let me see. You have the item count, and then you have this. Oh, so this is the order in which everything is in. Yeah, so I'm just gonna say while it's greater than 0, that means there is information to read, right? So since there is information to read, if it is greater than 0, then that means there still is information to read. And then now I read each piece of data. So I'm gonna start with item count, right? So I'm gonna create an int item count is equals to data input, and it's an integer, right? So I'm gonna call the read int function, which reads an integer from the binary file. So the different functions we have, right? Before we continue, we have read int, which reads an integer. Then we have read UTF, which reads a string in UTF format, right? And then we have read Boolean. You get the point. We have read double. Yeah, you get the point. Read float, all those functions. So that's how we read. And then write is write int, write UTF, write Boolean. That's the differences between the two. So after reading this, I'm expecting a player ID, which is a string. So I'm gonna read UTF. I'm gonna call the read UTF function. So there's a player ID is equals to data input dot read UTF. And then, I mean, we could, let me see. Technically, we could. It's a tricky thing, but technically we could just, after reading the item count, right? We the whole line. We can read the whole line and then split it up into tokens, right? We could do that, but I don't want to risk in doing all of that. So what I'm going to do, I'm going to read each information one by one. So we have the player ID. We have the role, which is also a string. So I'm going to read the role string. Role is equals to data input dot read UTF. Then we have the prowess, which is an int. So int prowess is equals to data input dot read int. And then the double mana equals to data input dot read double. Without the data input stream class, wouldn't be able to read primitive types. So this data input stream class is powerful, and the buffered input stream class wouldn't be able to do this thing really fast. So the buffered input stream class is also very important. So now we have all the pieces of information to instantiate a player or to create an instance of a player. If I check my player class, right? There's the player class. That's the name, and then it has two different types of constructors, right? So there's two ways I can go about doing this. I can use the default constructor to instantiate a player, and then call the setters to set the individual instance variables. That's the first method. And the second way is to just use this constructor to initialize everything, to instantiate, excuse me, to instantiate and initialize everything. So there's something very important here that I would like to emphasize. So this line of code, right? There's a function that does that. There's a function that does that. So you could just call set item count and pass item count instead of rewriting this code. Because if you look down there, there's the code. So what's the point of rewriting it? So we can just call setters here, set item count. And then I'm gonna call set player ID. And then I'm gonna call set, what was it? Set role. Then I'm gonna call set prowess, and then I'm gonna call set mana. You don't have to do it, but I'm just saying, I mean, you have setters, right? Mutators. Why don't you just use them and not rewrite code? So yeah, it's the same thing. You can still leave it the way it was before. It's still the same thing. Let me see what's going on here. It needs, so that means each of these it's gonna need a serializable ID. I don't, let me just see. Yeah, let's just add a default. So it needs a serializable ID to be able to identify or to distinguish the data for each object, I think. So yeah, I didn't see it in the textbook though. Yeah, I didn't see this piece of information. So I'm just going to add a suppress warnings there. You can add it. You can just right click and say add a default, some default. You could do that, or you can just suppress the warnings. You can also do that. So that's what I'm okay. Just for the sake of, I don't want it to give me surprise me here, and what I'm gonna do is I'm just gonna use the default serialization ID, a default one. I'm just gonna create default one. And then let's create an instance of player. So I'm gonna call it player is equals to new player. Right, and then I'm gonna pass in that information. Item count, player ID, role, prowess, and man. So there's the instance that we've created. Then now remember we have a list. So every instance that we've created, we need to add it to the list. So I'm gonna say players.add to add it to the list. So players.add. I hope it doesn't give me problems. Okay, no problems. So you should say players.add to add to the array list, to the list, add to the list. So it's going to add to the list, add what? This player, this instance that I've read from the file. And remember, while read is greater than 0 just means that while there's still input, it's like, this is like sort of like equivalent to while scan dot has next, right? Or has next line. Equivalent to that. I'm just trying to make sure that there's still information to read so that I read information for all the objects. The thing is, they gave you the data format, right? It's in this format. They didn't say in terms of objects. If they said in terms of objects, it would have been way easier to write, but yeah, we're just gonna write it, do it like this. So I think we are pretty much done reading from the file. Now we need to write to the file. So we scroll down here, we get here. So writing to the file, right, it's exactly similar to this. It's similar to this. The only difference is that now we are no longer using the input stream. We're using the output stream. And we are writing objects, not data. So I'm going to use an object output stream class. So let's do that. So I'm going to need a try catch block, and then it's going to catch an IO exception ex. Ex.print stack trace complaining because there's no code that raises that exception, but it's fine. So remember, we are writing to the file, so that's output. It's like we're outputting to the file. It's treated as output to a file. So I'm going to use the file output stream class. I'm going to call it fout is equals to new file output stream. Then it takes in the file handle, file that we want to output to. Then import, and then remember we need to pass it through the buffered output stream. Buffer out is equals to new buffered output stream, which takes in that file output stream. And then we now pass it to the object output output stream obj out is equals to new object output stream, which takes in that buffer and I read from the buffer. So it needs to take in that buffer and import. Yeah, and then I'm gonna go through my list, array list, and then write the object. This is actually gonna be a very simple implementation, to be honest. I'm gonna show you. So let's write to the object, so to the class, right? So remember, I'm using object output stream. I could have used data output stream, but then I'm not saving it to the file as data. They said you should save it as objects. So I'm gonna use an object output stream class, which saves the instances as objects instead of output, instead of data, instead of primitive types. It's going to save it as instances instead. So there's the write object function that we use that's inside the object output stream class that we use to write objects. And then you pass an instance that you want to write. So remember, we have a list of players. So we have more than one player. So I need to say for, let's just use a for each loop. Yeah, for each loop is safer. So for each player, colon, then what's the list? It's players list. So for each, so what the for each loop does, right? If you remember, it goes to this list, takes the current instance, and then saves it into this variable. And then it executes here, and then gets here, and it's like, oh, okay. So it goes back again, needs to go back to the top. While there's still an instance within this list, it keeps taking the current instance, saving it inside this variable called player in all lowercase characters. And then it executes this block within the opening curly brace and closing curly brace. So the simple line of code to write here would be, let's just say write object to file. So let's write the object to the file. How do we do that? We call the instance of object output. Remember, object output is a class for outputting objects or writing objects to a file. Dot write object, which takes in an object. What's the object? Is the player. Is the current player object that we have. So it's gonna actually store and write all the objects to this class. Or it's gonna write and store all objects in this list to the file that you're gonna specify through this file handle. So that's the code, and I think we should be done now. Let me just check. Let me go to main. Yeah, I think we just left to do main now, and then we'll be done. They made a mistake here. Why they're saying all the provided text files? It's not a text file. It's a binary file. It's binary files. So the main class, so you don't really need to worry about the main class. So the main class is this. It's 2 marks to read, just read, calling the read function. Sorting is 6 marks, and then write file is 2 marks. So all in all, it's 10 marks out of 60. So, and there's a 5 mark. There's 5 marks. You see, for Javadoc, coding convention, packages, commenting, Javadoc, there's 5 marks for that. So don't lose 5 marks for nothing. So we'll sorting is not a problem. So let's call, they said we should what? I need to read the instructions carefully. In Java, in the Java project, create the main class that will be the entry point of your main program. The main class must make use of the file handler to read and process all the provided text one at a time. Okay, so we're reading all the classes, the files. First, read the file with read player data method to get a list of players. Sort the list and save the list to a new file with the right object method. So we are reading the file with the function, with the method to get a list of players, and then that returns a list of players. Sort the list and save the list to a new file with the right object method. Oh, okay, so they want us to sort, and then after sorting, we return, which is basically this. So let's see how we do it. So it's gonna, we know that it's gonna return a list of players. Then I'm gonna call it players like this, and then import list, then add, import this. And then I'm just gonna write everything in one line, and I'm not gonna add too many lines. So we have player file handler class dot read player data, which creates a new, okay, so being what I didn't want to do. So file is equals to new file, creating a file handle, which takes in the file name. Okay, it's in the data folder, it's not in the source folder. So look, go into the data folder. After going to the data folder, read fantasy. Let's use the small one. Let's say read fantasy small, right? Fantasy small dot pet. So we're gonna read the small one, and then it needs me to import, and then it's gonna be file, and then they want us to sort the list. Is it? I think there's a, yeah, there's a. How do you sort? I'm not sure. I think this is how you sort. I don't know what function it's expecting. I forgot the. Yeah, but I think this is how you're gonna sort it. Unless, let me see. Yeah, that's how I'm gonna sort it. I'm just gonna leave it like that. So we've read from the file, which is this line. So this line will give you 2 marks. Just this one line that I've highlighted, 2 marks. So this, I'm not sure how they want you to sort. Let me see. And we're sorting in terms of what? That's the thing. Oh, now I see. So the thing that you're gonna use to sort is the compare to function. Yeah, which is, yeah, which is very, which is a very important thing. If you didn't implement the sort function, the compare to function, you won't be able to sort. Remember, compare, it compares, right? So yeah, we're gonna need to compare, use the compare function. So the way I'm gonna do this, right? Let's see. Compares.sort. Right, source this list according to the order induced by the specific comparator. The sort is stable. This method. Okay, so it wants me, yeah, like I said, c.compare So we need to call we need to make use of the compare to method. But the question is, how am I supposed to use it? Using the specified comparator, that is EC dot compare to. I don't know, but I'm assuming this is gonna sort. I'm not sure. If it doesn't sort, then it means I would have to, what does this use? I'd have to use a for each loop or a for loop, and then sort it into, sort it into a list. And then yeah, let's do that. Let me use a list. So it wants me to sort, right? So I'm gonna create a list of player, and then I'm just gonna say sorted. I call it sorted players, right? And then remember to instantiate it. We're gonna say list dot off like that. That's how we're gonna initialize it to an empty list, and then once we've initialized this sorted list, right? I'm gonna go through each object, right? So int I is equal to 0, I is less than players dot size, right? I plus plus. Remember, the size returns the number of items, in this case, number of player objects that are there in the list. And then I think there should be, let me see, players that, yeah, we should be able to get, yeah, we could also use iterators, but I'm going to use the get function, which returns an element or the player at the specified object. So what I'm going to do, right, I'm going to get player 1 and player 2 and then compare. I'm going to say player. So that means I need to stop before the size. So I need to stop before the last element, right? So let's talk about how I want to sort it, right? So remember, I'm gonna have, let's say 1, 2, 3, 4, 5, 6, right? This is the index 0, this is the index 1, index 2, index 3, index 4, index 5, right? So what I want to do is I want to store, let's say num1, which is number 1, then num2 is the integer number 2. Then I want to compare and check, is num1 less than num2? And then if it is, then I need to add num1 to my list, right? So sorted, let's say here it's going to be called sorted whatever dot add, then I add num1, right? And then, but then if I'm using indexes, right, what would be num1's index? Num1's index would be index 0, or index I if I'm using that variable I. Then what is index? What is the index for the integer number 2? Look at integer number 2. The index is 1. How did we get 1? We said I plus 1. So you get the next element, and then you compare. But then here we won't use this for remember, we have objects. We're not going to say less than, we're going to say dot compare to. We're going to use the compare to function. Then after comparing, we check if it is less than. Then if it is less than, then we store into the list. So, but then remember, we're going to keep getting. So I'm going to get this, and then I plus 1 is this. Now I'm here. I'm going to compare 2 and 3. 2 and 3, this is that one there. and then I'm gonna compare. I'm gonna compare this, and then this will be I. This will be I plus 1. And then this becomes I. This will be I plus 1. And then this becomes I. This will be I plus 1. And then now, and then this will be I plus 1. So if I say I plus 1, if I say I don't know how I'll explain it, but you can see I'm gonna need to reference the next index, right? So that means for my I need to make sure that for this for loop, I need to make sure that I don't reach the end, because if I reach the end, which is index 5, I'm gonna say index I plus 1, which is index 6, and in this case, it doesn't exist. So I need to make sure I stop before my last index. So I'm going to subtract 1 there, which is going to make me stop before the last index, because I'm going to get the not it's going to stop before the last, not the last index, but yeah, okay. So let's see. So the difference, which one is smaller between the two? The one smaller between the two, okay. So the one smaller between the two is going to be stored, right? So we're going to have this and that, and then so that means the last value. Yeah, that means the last. Let me see. The last value is it's going to be. Is it going to be in the in num1 variable or player1 variable? Let me think. Okay, let's write it before, because there's something that I want to check here. So you can have player1, right? And then how do you get this player1? We remember we read the file and then stored the players into the list of players named players. So I'm gonna say players dot get index I, right? And then I plus 1, it won't exceed the index. As you can see here, it will never exceed the index. It will never go beyond the maximum index, so I don't have to worry about that. I don't have to do error checking there. Okay. List called sorted list. So I'm gonna call the compare to function. I'm gonna say if player1 dot player1 dot compare to, right? Compared to the other player, if the value is less than 0, then, because remember they said it should be sorted, so I'm assuming it's an ascending order. So I'm just gonna say I'm gonna start from smallest to biggest. So that means I'm expecting this one to be smaller than this, right? So it should be, this should be smaller than this. If it is smaller, okay, let me create a player variable to store the max, right? Let me just instantiate it in new player. This will help us keep track of the, let me say minimum, because, so I'm gonna say minimum is now, this reference is player1, right? That should be my minimum. And then else if player1 dot compare to is greater than 0, right? If it's greater than if it's greater than 0, that means this one is That means this object is greater than this, which means player 2 instance is the one that's less. So since that's the one that's less, that means player 2 would be the new minimum. And then at the end of the day, I need to add it to my sorted players list. Add sorted players list. And then just to make sure that everything is indeed stored in the right way, I need to remember let's look at how it's gonna work, right? It's gonna compare these two values. Which one is smaller? Store the smaller one into the store the smaller one into the let me see. Yeah, this is not the right way. So I should actually initialize this to this, right? So I should initialize it to the first index, right? Index 0. And then compare it to the current instance. So 1, and then let me call this one player 1, and then let me call this one min player 1. Then let me say player 1. If player 1 is smaller than the current minimum, if player 1 is smaller than the current minimum, then I should update my minimum to be player 1. It's sort of like, if you remember that maximum algorithm for integers, or any maximum for doubles, as long as it's a normal, we're doing the same thing for objects. It's somewhat similar. Then if is greater, if it is greater, if this is greater, that means this is the minimum. So that means we won't do it. So that means this line needs to go away now. So this is fine. So compare player 1 with the minimum. Whatever that minimum is, then add it there. But then I think there should be a better way of writing this. I'm not sure, but there should be a better way. So what's going to happen is, right, let me show you what's going to happen. What's going to happen is, let's say the difference between, let's compare these two things. Which one is less than the other? One happens to be less than the other value. Or let's say it was this case, right? 2 and the 1 there. So 2 would be, 1 would be less, right? Okay, this is trick. I don't think this is how I should do it. I'm not sure how they exactly want you to do it, but thinking about it, it doesn't really make any sense when I think about it in that way. So I think when you call this sort function, you should hypothetically compare, right? You should use the compare to for these objects, since we defined the compare to function. I'm just gonna leave it like that, like this for now, and then we'll get back to it. I'm not really sure how they want you to sort it. So let me call player handler dot write player object, right? Let's create a new file handle, right? So go into the data folder and then save. Let me call it fantasy. Let's call it output.dat, right? Something like this. So I'm not sure Let's run it and see. Okay. Yeah, I was thinking about it. I don't know why is it the sort? Yeah, I think it's something I did wrong here. Let me just remove this for now. Yeah, I'm not sure about the sort. I'll let's see. I'll just check it out in the textbook and see how they wanted you to approach it. I'm just gonna check it out in the textbook. Let me see. I did run. Okay, we did run, but then there's no output. Let me see. How do they want us to display this thing? Okay, so what I would do, right? Since I'm reading player objects, right? I'll generate, I'll make this class generate a toString, right? So let me go down here. And then I'm going to use the toString to output data. Yeah, let me just leave it like this. So after reading from the file, we're gonna output the information, right? So let me, you can use this for each loop like this. I'm just gonna use this for loop and then name each value player. So this variable is gonna take in each player object and it's gonna be stored in here. And then this arrow is I won't talk about too much, but it's just going to help us to output to execute something within this curly braces. So what's going to be executed here? I'm just going to output the player, right? Dot toString. Let's see if it's going to output. Is it even running? What's going on? Okay, let me do this. Run as Java application. Smaller that. Okay, let me say large. Then output. Okay. Where did I go wrong? Let's see. Okay, let me do this. Let me store one object and see if that'll work. Okay, yeah, now I see. But I remember, I don't know why they're saying it's a list. Yeah, but I'm gonna do this, right? Let me use an array list. Let me use an array list instead. Because I think the last time I recall, the list is immutable. You can't mutate or change a list. The list interface is actually supposed to be used. Come on, why is okay. It wants me to do that. Okay, so let me see. Let me just return a list, right? But then the list is gonna be, when I return it, it's gonna be a list, but it's an array list. Let me check if that's gonna make a difference. Okay, let me go back to commenting out these lines. Just read one piece of data. It is reading, you see. So that means there's the data, item 50, blah, blah, blah. Yeah, so it is reading. So that means something is wrong here with my while loop. So something is wrong with my while loop condition. So, and that's the large. I just read in one line. So what's the issue here? Let me do this. Let me use F in. Okay, it still doesn't want to work. Okay, because I know the read function, it checks if there's still input or there's still something to read from the file. So let me check. Let me do this. See if there's a function inside the data input stream. Oh, yeah, I think we have to, yeah, I think we have to use the, let me see. Yeah, I think we have to use the available function. What does it return? An estimate of the number of bytes that can be read or skipped over from this input without blocking. This method returns a result of input.available. It returns an estimate of the number of bytes that can be read or skipped over from this input stream without blocking by the next caller of a method for this input stream. A single read or skip of this many bytes will not block, but may read or skip fewer bytes. Come on. I think it should be available. Let me see. Let me check. Okay, it's not. Come on. What's the issue here? How is the player ID? Let me see. Where it is UTF though. Let's look at what they said in the question. They said it's a unique player ID of the player, which is a string. So this is the odd numbers. We have item count at the top, and then we have player ID, which is a string, followed by the role, which is another string, followed by the prowess, which is an integer, followed by mana, which is a double. So, or maybe they stored still strings in a different way. So let me see. This dot does not convert to one. let me think, but read UTF should be working. I don't know why it's complaining. I don't know how the data is saved then, because it is reading one of the inputs, but then it's complaining. Or maybe there's, I don't know how many items are there in the file, but then there should be more than one at least that I know. So while data let me see, null pointer, null input stream, read UTF wait, reset, notify all, mark close, blah blah, transfer to, skip long, read line. Why is it being weird? Okay, let me do this, but this wasn't working. But just try it again. Okay, now it's not even reading anymore. I think it should be the available function. I think so. I think it should be the available function. It's just complaining, but it's not. I'm not really getting why it's complaining. It's end of file. It is. Is it saying it has reached the end? Or what? Is there one object? What's going on here? But then there should be multiple objects that I know. Just give me a sec to decipher this thing. Well, input, data input that available is greater than 0. Yeah, the function is fine. Returns an estimate of the number of bytes that can be read or skipped over. The next column might be, yeah, it's the available function. Let's try it with a different file. Let me see. I don't know what's going on. Okay, so the there's the player ID item count. Okay, what's going on? Why isn't it storing the integers? Okay, let's do this. I don't know what's going on. The strings, I mean. So let's say read line. Okay, that's not, it's deprecated, so it's no longer used. Okay, so I can't even test with that. But they said that's the syntax, that's the order in which the information is stored in. There's the item count, which is an integer. And then we have, yeah, if you if you go down here, it says the file handler should read and process all the provided text files, right, one at a time. First, read the file with read player data method to get a list of players. Sort. Okay, so let me do this then. So they want us to say small. And then file. So let me say players1 here. The new file, data fantasy small.dat, and then players. Let's make this players2, right? With players2. Okay, we have this. Then medium, because they said to read all of the files, right? So I'm just gonna put the 3 lines of code there. Players3, and they said it returns a list. Let's go back, and it returns a list of players read from the file as objects. Currently, data stored in using only primitive types. So we did the right thing. The files are stored in the following format. So we use the data input stream, so it's correct here. It's stored in the following format. It requires conversion of these files into a new binary format that uses Java objects instead. Oh, yeah, so it's important to read. So it was stored in text format, so they want us to read and store it back and store it in terms of objects now. Okay, so I think I have a trick. Let me see. It returns. Okay, I don't have a trick for it. So what I would do, right? I'm just gonna have one players. The first one is gonna be called players, and then the second one, and then this is gonna be large, right? And then I'm gonna add players2. Okay, this thing is really tricky, and I don't know why they want you to use an array list. Let me just change it to an array list, because what I can't accomplish what I want to accomplish now because of requirements of the paper. Oh, yeah, I need to, I'm adding a whole array list. So I need to call the add all, which adds a whole collection, right? So let me see now. Okay, so there's three. Yeah, there's three objects, right? Yeah, this thing was a bit tricky. They're not straightforward. So that means I don't actually have, that means each file has one object, I'm assuming, or one object. So I'm just gonna do this. So I'm gonna do this, and then let's run it again. Yeah. So now it's fine. So that means this files don't have more than one object. But if it had more than one object, you'd use the available function. That's one thing I'm seeing here. The problem is I can't see because it's in binary. I can't read it inside Notepad++. I just had to figure it out. But yeah, it's three objects like this, right? So I don't know why they're making this thing complicated, because if you use a list, remember a list you cannot modify. So you can't even add the objects. So the best way to avoid it, even though they said they actually expect you to use a list, just use an array list instead, because you can't add objects to the list. So yeah, that's everything. Now code should be, it's fine now. The only problem is the sorting part. The only problem is the sorting. Let me think. How would they want you to sort this thing? Yeah. Yeah, I think, yeah, let's do it like this. So you would have to sort, right? To sort, you'd have to call the collections, right, class, and then you call the sort method, which takes in a list. Then you pass in the list, which is players, and then done. Sorted. But in order to sort, you need to define the compare to method. So if you go down here, there's the compare to method. It has been defined. So yeah, I forgot, it's the collections class. One here. Okay, I don't have to say sorted players. I just call it players. So yeah, you always call collections dot sort, and then you pass in the list. The question is, since what we are done, yeah, everything is fine now. If we check, there's the output, everything is fine. If I look here and I refresh, there should be a fantasy output dot this folder. Yeah. So we have written the objects to the file. So one thing that I want to make sure of here is the list. How are you gonna add? Because they said it's gonna return a list, right? I'm just gonna use an array list. Just use an array list. If you just use an array list, because if you use a list, you can't add. You can use the add method. It's immutable. Immutable means that you can change the list. So becomes a problem because now you're gonna have three lists that are immutable. So you can't call the add all method to add. You get what I'm saying? You can't add things now. So I'll just stick to the array list. So this is how I think, this is how I think we should have approached it. Remember, there's 3 lines, right? These 3 lines just translate to me doing this, doing a for each loop, and then doing like this. You could write it like this and say player, player, then you pass in the list or array list, and then sys out, then player dot toString. Then it's gonna work the exact same way. Or you can just omit, you don't explicitly call the toString, but the moment you pass it out, is you pass out, you output an object, it calls the toString for that object. So you don't have to explicitly call it. And you save and then you're done. So that's it. Yeah, it's almost 3 hours. This is a long video. That's it. I'll see you in the next video. I'll do question 1. Binary is a bit tricky, but that's binary. We'll continue with the same question paper and do question 1. Question 1 should be fairly straightforward. Thanks for watching. See you in the next video.